Okay, so in this particular video, I'm going to briefly describe some properties of real numbers, and then I will proceed into simplifying some algebraic expressions. I just want to mention the properties of real numbers, things that you can do with real numbers, and the result of that, the results of that. So the most famous property that we probably know very well is called the distributive property. And the distributive property means that we could multiply, okay, um, we could multiply or distribute across addition. So, for example, or I should say multiply across the parentheses. So what I mean by that is I take 3 and I multiply it with the 4 and then with the 5. So when I do that, I'm doing 3 times 4 plus 3 times 5. And that's called that's an example of a distributive property. Okay? So we're multiplying across the parentheses. And we're going to talk more about that when we do examples of simplifying algebraic expressions. We'll have examples of when we will distribute across the parentheses. The next property is called the commutative property of addition, and that's basically you can add anything in any order. So A plus B equals B plus A. It doesn't matter the order because you're going to get the same result. For example, 3 plus 4, okay, will in fact give me 7. And when I do 4 plus 3, I will still get 7. So the order does not change the answer that you will get when you add these two numbers up. All right? Same thing with multiplication, okay? You can take it as called the commutative property of multiplication. Again, you could take any two numbers and multiply it in any order. For example, 3 times 4 is the same thing as saying 4 times 3. Okay? So you're still going to get 12, and then 4 times 3 is also 12. So the order does not matter. You're still going to get the same result. The associative property of addition, all right, is that we're adding in this particular example, we're adding 3 quantities, 3 plus 4 plus 5. And I want you to notice something. 3 plus 4 plus 5, and you notice the order, 3 plus 4 plus 5. The only difference is that I'm adding in the first part of this, I'm adding the 4 and the 5 first. So when I do 4 plus 5, I get 9. Then I add the 3, I get 12. Okay? Here, I'm grouping the 3 and the 4 first. So 3 plus 4 is still 7, and when I add the 5, I still get my 12. So that is called the associative property of addition. That means I can group or add numbers in a different way, and I'll still get the same result. Okay, so this would be, it's like regrouping, you know, it's kind of like, okay, what do I want to add first? I want to add the 4 and the 5 on the left side, then add the 3 last. And that's the same thing as saying, okay, well, I can add the 3 and 4 first and then add the 5, and I'm still going to get 12 on both sides. Can you see that? It doesn't impact the final answer. Okay? The associative property of multiplication is similar. Okay, the order is the same. 3 times 4 times 5 equals 3 times 4 times 5. However, it's the way that I start the problem. On the left, I'm doing 4 times 5 first. We all know 4 times 5 is 20. If I times that by 3, I'm going to get 60. Well, what if I group the 3 and the 4? And what if I do 3 times 4 first? Well, 3 times 4 is 12, times the 5 last, still going to be 60. So therefore, that's called the associative property of multiplication. Okay? And then the remaining identities are fairly simple. Okay, the additive identity property is basically you're taking something, you're adding 0, and you get that same initial amount back. For example, if you have 4 and you add 0, well, 4 plus 0 is still 4. Okay, you're still going to get your original. So we started with 4 and then we ended up with the original amount because we're adding 0 to it. That's called the that's called the additive identity property. The multiplicative identity property is is anything times 1. So in this case, 4 times 1 is that anything right back. Okay, 4 times 1 is still going to give me 4. 5 times 1 is still going to give me 5. 7 times 1 is still going to give me 7. X times 1 is still going to give me X. Okay? That's called the multiplicative identity property. Anything times 1 will give you that same amount right back. And then we talked about additive inverse. Remember we talked about this a while back. If you start off with a quantity and you want to add its inverse, well, the inverse is its opposite. So in this particular example, we started off with 4, and if we add the opposite, okay, well, 4 plus a negative 4, don't forget, a plus and a negative is a negative, so 4 minus 4 will give me 0. Let me just reiterate that one more time. Okay, so over here we said a minus and a negative is a negative. So when we do 4 minus 4, we get 0. Okay, so when you think of this, negative 4, think of the opposite. The opposite of plus 4 is negative 4. So when we add an opposite, we always get 0. Okay, that was one of the properties we talked about, remember, a couple of weeks ago. Okay, and also multiplicative inverse property. Again, we mentioned this before. If you take an initial quantity and times it by its reciprocal, you'll always get 1. So if you look at 4, okay, and you do the reciprocal, well, the reciprocal of 4 is 1 over 4. What happens to the 4s? The 4s will cancel out, and you're just left with the 1. Okay? And that's why it's equal to 1. So these are just some very basic properties of real numbers, and just something to keep in mind. Okay? But the other part of the lesson, the main focus now, is going to be simplifying algebraic expressions. Okay? So we're going to be simplifying algebraic expressions. Okay? All right. So, first thing that we want to clarify is we want to know a term. Okay, and a term is basically, it could be a constant, okay, which is basically just a number, okay, or it can be a variable, or the product of a constant and a variable. Okay, so let me give you an example of all this, okay? So these are examples of terms, okay? We said that a constant, okay, the first one was a constant, right? So that would be like, for example, 8 or negative 2. That would be a term, okay? 8 is a term, negative 2 is a term. They can be both positive or negative, it doesn't matter, okay? Another thing it can be is a variable. And a variable, so for example, x or y, okay, doesn't really matter, okay? That could be a term. So x is a term, y is a separate term, a different term. Just like 8 is a term, -2 is a different term. But they're the same type of terms, right? And then you can also have the product. Okay, the product. So the product of a term and a constant, for example, would be so product of a constant and a variable would be like 2x or 5y squared or x squared y cubed. Those would be examples of terms with different variables, different exponents. Terms can have exponents, okay? They don't always have to be numbers or variables, okay? So these are all examples of terms. So if I give you a polynomial, okay, let's say I give you -6x squared plus 5y minus 11, then you're going to say, okay, this is the first term, -6x squared. And then you have 5y plus 5y. That is your second term. And then you have -11, and that is your third term. So you have a total of 3 terms in here. Okay? So you have a total of 3 terms. Okay? So, and I'll explain what a polynomial is, okay? A polynomial means many different terms. So here we have 3 terms. That would make it a trinomial, okay? And I will go over the classification in a moment. But right now, I just want you to understand what a term is, right? A term can be a constant, and in this case, the constant is -11, all right? So let me just make a note of that, all right? So the one in this color, that's your constant, which is just the number, so that's -11. Okay, your 5y is the product of a number and a variable. Product means multiplication, so 5 times y is 5y. Okay, and then the other term, the first term, is the product of -6 and x squared. When I multiply those two together, I get -6x squared. That's the product of those two things. Okay, so now you have a better understanding of what terms are. Okay, let's go ahead and talk about like and unlike terms so we know how to combine them later on. Okay, so the first list I'm going to make is called like terms. And like terms, example would be like -6t and 4t. They both have the letter t, even though the numbers are different, that's okay, but they both have a t attached to it, so those are considered like terms. Okay, another thing would be 1.8 ab and -3 ab. Even though the numbers are different, but they both have ab's attached to those numbers, so those are called like terms. Okay, and you can also have 1/2 c squared t cubed and c squared d cubed. Again, different numbers. This has a 1 in front of it, but they both have c squared d cubed, okay? And those are considered like terms. Now, the other thing is you can have unlike terms. Whoops. Unlike terms. Okay? So, this is the first thing, and this would be the second, okay? So, unlike terms, an example would be like negative 6t and 4a. Okay, different variables attached to those numbers, not going to be the same. Those are unlike. Okay, you can have 1.8 xy and negative 3x. Again, they both have x, but one of them is missing the y. The negative 3x doesn't have the y. So those are different, okay? One different variable can make it a different term entirely, all right? They both have the same amount, the same letters in each term. If one differs, then it's not considered a like term, okay? So let's say you had 1/2 c squared d cubed and c squared d. You notice the problem with the exponent. This is d cubed and this is just d to the first power. Those are different exponents. In order for terms to be the same, you not only have to have the same variable, but you must have the same exponent for each variable. So we both have c squared, that's fine, but the d cubed and the d to the first power are different, so those make those unlike terms. Okay? And there's an imaginary 1 here, just so you know, okay? But that's not going to change anything. They're still different terms, okay? So we want to make sure that we understand what like terms are. And we will get practice when we do the simplifying of algebraic expressions, okay? So my next thing is this word here. Okay? And these basically is the number to the left of the variable for each term. So let me give you an example, okay? So let's say I gave you 2x cubed minus 2x squared plus x minus 1. So we have a polynomial with different terms, right? So again, we want to identify all the terms, right? So there's 1, okay, 2, 3, 4. Okay, so you can say the terms would be 2x cubed, comma, negative 2x squared, comma, x, comma, and minus 1. So those are the 4 terms that we have, okay? This is your first term, this is your second term, this is your third term, this is your fourth term. So you have a total of 4 terms in this polynomial. The coefficients, okay, the coefficients would be this this number here, okay? So it would be 2, okay? So right here would be 2, and then this one, -2, so I'll put commas. And then this one is going to be a 1, there's an imaginary 1 in front of that x. And then this is a coefficient, even though it's a constant, but it's still a coefficient, okay? And those are the 4 coefficients, okay? So your coefficients would be 2, -2, 1, and -1. And they just tell you how many terms do you have. So when you look at x cubed, which is the first term, the 2, the coefficient of 2 tells me we have 2x cubes. The -2 tells me we have -2x squareds. The 1 tells me we have 1x, and then the -1 is just a negative, it's just a constant, okay, coefficient. So you have those 4 coefficients, and the 1 that is this one, the -1, is called a constant coefficient. All right? So I'm just getting you familiar with terminology so you can identify things with the proper terminology. So when I say, okay, class, what are the coefficients, what are the terms, you will understand what I'm talking about as far as like terms, unlike terms, and things like that. Okay? So that's all there is to it as far as identifying the terms and coefficients. All right? Now let's go ahead and do some problems where I want you to apply some properties. Okay? So the very first one is this. And basically what we're going to do is that when we have something outside the parentheses, we're going to have to multiply it by everything inside, and that is called the distributive property. Okay? And we'll use this property very often. Okay? So we're going to do the math here for the algebra. 4 times 2x. Okay, so that's what we're doing. So we're doing, let's use a different color. 4 times 2x plus 4 times 5. Okay, and that's going to give me 2 times 4x is 8x. Just attach the x with the number. Plus 4 times 5 is 20. Okay. These are unlike terms, so we cannot add the 8 and the 20. The 8 has the x, and the 20 is just a constant. So this would be the final answer. Okay. And just as a little footnote, these are unlike terms. Okay? One has an x variable, one's just a number or a constant. All right, so let's do another one. Okay. All right, so now we're going to take the -3 and we're going to use the distributive property to multiply -3 with everything inside the parentheses. All right, so we're going to do that from left to right, okay? So -3 times a is just going to give me -3a. Actually, let me go ahead and show you what I'm doing here. -3 times a plus -3 times 2b plus negative 3 times negative 5c. All right, so remember, negative 3 times a is negative 3a. Just put them together. All right, a positive times a negative 3 is a negative. And then 3 times 2b is 6b. All right, a positive times a negative, when we do this, is a negative. And then 3 times, negative 3 times, a negative is a positive. Sorry. Looking at the wrong sign. So a negative times a negative 3 times a negative 5 is a positive 15c. Okay, so let's make sure we understand that we're multiplying negative 3 times a, negative 3 times 2b, and negative 3 times 5c. Okay, so negative 3 times a is negative 3a, and plus times negative 3 times 2b is a negative 6b, and a plus times a negative 3 times negative 5c is a plus 15c. Okay, so you got to watch out for the sign changes, right? So we got to be really careful with that. All right? And that's it. We can't combine these terms because they're all different. One has an a variable, the other one has a b variable, the other one has a c variable. So we're not going to be able to combine like terms. So as far as we're concerned, we are done with the problem, and that is your simplified algebraic expression. Okay? So let's go ahead and do another one. Okay. And we will do one more, okay? So let's do fractions. Negative 2/3 times negative 9x plus 3/8y minus 5. So we worked a lot with fractions already, so we should be very comfortable with fractions. So we want to make sure that we distribute negative 2/3 with negative 9x, positive 3/8y, and negative 5. So what we're going to do is we're going to take negative 2/3 and we're going to multiply that by negative 9x. All right, and then we're going to add, okay, and then we're going to have minus 2/3 times 3/8y, okay, and then we're going to do a negative 2/3 times negative 5. Okay, I don't even know why I even wrote this here. That's redundant. Okay, so we just go ahead and multiply those three things together. Okay, remember a negative 2/3 times a minus 9 should give me a positive. Okay, so when we do this, okay, what this really means is this means negative 2/3 times negative 9x over 1. Let me use the multiplication symbol. So it's like a fraction, right? A negative and a negative is a positive. We know that, okay? And then now we just multiply straight across, okay? So, so negative 2, multiply straight across. So negative 2 times negative 9x is going to equal 18x all over 3 times 1, which is 3, okay? And then we can reduce this after. Let's just focus on multiplying everything together, okay? So this, when we multiply these two together, okay, we have negative 2/3 times 3 over 8y, and then we just multiply straight across. Okay, that y really is in the numerator, so when we multiply, we just do negative 2 times 3y, which is going to be a negative 6y. Okay, put that on top. And then 3 times 8 is 24. Okay. And then now go ahead and do the other two. I'm sorry, so we did this one. This one here, we're going to write as negative 2/3 times negative 5 over 1, and then we multiply it straight across. So a negative and a negative is in fact a positive. 2 times 5 is 10. 3 times 1 is 3. Okay? And now we just want to reduce each fraction when possible. You notice that I can cancel the 3 and the 18. 3 goes into 3 once. 3 goes into 18 6 times. So my new fraction is going to be 6x, okay, over 1 minus, and then 6 over 24, 6 goes into 6 once, 6 goes into 24 4 times. So my new fraction is minus 1 over 4 y. You could put the y in the numerator, or you can put it off to the side. It's the same thing. And then plus 10 over 3. Now this 1 here is really not needed, so your final answer should be written as 6x minus 1/4 y plus 10 over 3. Okay, and just so you know, you can also write it as 6x minus 1y over 4 plus 10 over 3. You can put the y on top in the numerator or off to the side, but not in the denominator. Okay, and you can even get rid of the coefficient of 1 and just write y over 4. But this is fine in the box that I have it here. Okay, so that is called the distributive property. It's used a lot in simplifying algebraic expressions. Okay, so the next thing is clearing parentheses and combining like terms. So the next example I want to give you, okay, let me see what number, okay, to number them. So the next example that I want to give you is minus 4 minus 3 times 2x minus 8 minus 1. And the first thing that we want to do is we want to clear parentheses. And combining, sorry, we got a little bit, let me rewrite that. Okay, and combining like terms. So our first mission here is to think of order of operations. How do I want to simplify this? Well, it's the same thing that I taught you with order of operations. We want to clear all parentheses first. When you have something outside of the pair of parentheses, we're going to go ahead and use the distributive property. That means we take the -3 and we times it by the 2x and then the -8. And when we do that, we get 4. Now, -3 times 2x is -6x, and then a -3 times a -8 is a +24. Now, do I multiply the -3 with the -1? The answer is no, because the -1 is not in the parentheses. So we cannot distribute the -3 with the -1, so I'm just going to copy down the -1 just like that. Okay? And now what we do is called combining like terms. All right? So we look for things that we can add or subtract that are identical. All right? And here I see a bunch of numbers that we can do. We have the 4, the 24, and the 1. Okay? So when we do that, all right, we're going to do... we're going to combine like terms, so we are going to, if it makes sense, you can rearrange this, okay? You can do this. Four plus 24 minus 1. Actually, no, I wanted to do the numbers first. Actually, you know what? I'm just going to combine like terms. It'll be just much easier and less work. So we can just do 4 plus 24, which we all know is 30, right? And then you can do 30 minus 1. Did I make an error here? I think I did. 4 plus 24 is in fact 28, not 30. Okay, and then we have a -6x and a -1. And then we do 28 minus 1, which is in fact 27 minus 6x. Now we can't combine the 6 because it has an x attached to it. That's a different term. We are just combining numericals or numbers, okay, for this particular problem. So the answer would be 27 minus 6x, or the standard way of writing it is write minus 6x first and then the plus 27 last. That is a general way of writing polynomials, is you want the term with the variable first, followed by the constant. And I'm going to get into that habit of doing it like that. Okay? And that's how you clear parentheses. Okay? We can do another one. All right, so we have this right here. Plus 8 minus 10s. Okay, so this will be the last problem. And we're going to distribute the -1 here and the -5 here. Okay, so we need to distribute -1 times 3s and -1 times -11t. So when we do that, okay, we are left with -3s, because a -1 times a +3s is a -3s. A -1 times a -11t is a +11t. And now we're going to distribute the -5 with the 2t and the 8s. So a -5 times 2t is a negative 10t. A negative and a positive is a negative. So a negative 5 times a positive 8s is a negative 40s. Okay? And then, of course, the negative 5 and the negative 10s do not get distributed because the negative 10s is not in the parentheses, so we bring it down. Okay? So bring this down. And now we can go ahead and do what is called combining like terms. Combine like terms. So we start with all the terms that we want to combine. So let's look at the first term, s. Okay. We want all the terms with s in it. So here we go. We have negative 3s minus 40s minus 10s. So we go left to right. Negative 3s take away 40 more is negative 43. So if we do that off to the side, just so you know, okay, if you have negative 3 and you're taking away 40 and you're taking away 10 more. So negative 3 times 40, negative 3 take away 40 is minus 43. Minus 10 more is minus 53. So we're going to write that as minus 53s. And if it helps, you can cancel the ones we've combined, if that helps. And now we're just left with the t terms. So 11t take away 10t is going to be positive 1t or just positive t. So the answer can be written as minus 53s minus 53s plus t. That would be the answer right here. Okay? Okay. So that concludes how to simplify algebraic expressions.